Hello future interns, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now if you find my videos interesting and important to your studies, also please don't forget to subscribe. So we have here the first example on the construction of influence line, vertical deflection at point C of the cantilever beam shown. AI is constant. So I'll present two solutions here. The first one is by uh, superposition method on cantilever beams, and the second one is by uh, conjugate beam method. So here is the given cantilever beam, and we want to construct or draw the influence line for the vertical deflection at C. So this is the real beam. Now the loading is at C. So we make this as our moment center, point A, and D will be in this position or before C. So let's have uh, the load before C first. Remember, D is arbitrary. So this is X, this is 3 minus X. And the deflected shape would look as shown, so that the vertical deflection at C consists of moment at the wall, length square, which is in this case X square, over n plus 2, then plus this distance times theta, 3 minus x times theta. And theta is moment at the wall, length, which is x, divided by uh, degree of the moment diagram by parts, plus 1. So this is FCD. So EI, these are the formulas from superposition method. EI delta equals moment at the wall, L square over n plus 2, where delta is negative or downward deflection, and the other one, EI theta, is equal to moment at the wall length divided by n plus 1. So EI negative FCD equals 1x times x square over 1 plus 2. So moment at the wall due to this unit load is 1 times x, so 1x. The length is x, the distance of the load from the moment center x, so that's why you have x squared. Degree of the curve, because this is a concentrated unit load, so first degree plus 2. Then plus 3 minus x times theta. So EI negative FCD equals x cubed over 3 plus 3 minus x times theta is 1x times x over 1 degree plus 1, first degree plus 1, because this is theta. Simplifying, EI negative FCD equals x cubed over 3 plus 3x squared over 2 minus x cubed over 2. Combining like terms, so we have negative x cubed over 6 plus 3x squared over 2. So take note, this is negative, so this becomes positive and this becomes negative. Factoring out 6 in the denominator, so 6EI, so we have x cubed minus 9x squared. So if you check, we have x cubed over 6EI. This becomes positive, this becomes negative, then minus 9 over 6, which is negative 3 halves of x squared. This is for 0 less than equal to x less than equal to 3 meters. Now how about for the case where x is from 3 meters to 8 meters? So the arbitrary point D is now here. Then imagine that we apply one axiom of statics. So we add two forces in equilibrium. We had one downward and one upward at C. So one upward at C and this downward unit load will constitute a couple. So we now have unit load downward and a couple which is 1 times x minus 3. So this distance is x minus 3. So we have one downward and a couple which is 1 times x minus 3. So since the unit load is acting at C, the moment for the unit load is 1 times 3 over EI, and the other one 1 times x minus 3 all over EI, the couple. So EI negative FCD is equal to, or FDC is equal to moment of the wall for the unit load 1 times 3, length is 3 square over first degree plus 2. Then for the couple, the moment is 1 times x minus 3, length is 3 square divided by 0 degree for the couple plus 2. So 1 times x minus 3 times 3 square over 0 plus 2. Simplifying, that's 9. This is 9, then 9x over 2, then negative 27 over 2. So 9 minus 27 over 2 is negative 9x, negative 9 over 2, then plus 9x over 2. So since this is negative, this becomes positive, and that's negative. Factoring out 9 over 2 EI, then we'll have 1 minus x. So FCD is 9 over 2 EI times quantity 1 minus x. This is for 3 less than x, less than equal to x, less than equal to 8. So we have two equations. So let's now have the influence line for the vertical deflection at C. So the equation of this curve from 0 to 3 is given by this expression. 1 over 6 EI times quantity x cubed minus 9x squared, where the value just over C is, when x is 3, 3 cubed, 27 minus 9 times 3 squared, divided by 6. So that would be, this is the other equation, 9 over 2 EI, 1 minus x, which is a straight line going down. So this is negative 9 over EI, 3 cubed 27 minus 9 times 3 square, 81. So 27 minus 81 is negative 54 divided by 6, so negative 9 over EI. And here, negative 31.5 over EI. So that's it. So this is calculated by setting x equals 8. So 9 times quantity 1 minus 8. So negative 7 times 2, 9. Negative 63 divided by 2, so negative 31.5 over EI. This is the influence line for vertical deflection at C in meter per kilonewton. So that's it for this problem. So for the second method, let's have the conjugate beam method. So we have here the unit load acting over C. So the conjugate beam would look as shown. So this becomes free and this becomes fixed. And the moment is 1 times 3. So 3 over EI here. So this distance, so the arbitrary point D is before C. So we have x here, then this is 3 minus x. So this ordinate is by similar triangles. Ordinate as to 3 minus x equals 3 over EI as to 3. 3 over EI as to 3 is 1 over EI times 3 minus x. So that's why this is 1 over EI times 3 minus x. And let's now apply the FDC, which is equal to FCD. And this is theta D. The positive direction is downward, considering A and D. So the positive deflection is counterclockwise, and the shear, remember, is going down. Positive direction from conjugate beam method. So this is FDC or FCD, which is equal to FCD also. So let's divide this trapezoid into two triangles as shown. So summation moment at D, so that theta D will not be involved. So counterclockwise positive, so FDC plus 1/2 of x times 1 over EI times 3 minus x. Moment arm is x over 3. This is x over 3 plus 1/2 of x, height 3 over EI, then the moment arm is 2/3 of x, so 1/2 of x 3 over EI times 2/3 of x equals 0. So simplifying, this is x squared over 6EI times 3 minus x, so negative x squared over EI, this one, cancel 3, cancel 2, so negative x squared over EI, and this one is negative x squared over 6EI times 3 minus x. So negative x squared over EI minus 3x squared over 6EI, this is negative x squared over 2EI combined with negative x squared over EI, so that would be negative 3/2 of x squared, or negative 3x squared over 2EI, then plus x cubed over 6EI. So factoring out 6EI, then FDC, which is equal to FCD also, is 1 over 6EI, quantity x cubed minus 9x squared for 0 meter less than equal to x less than equal to 3. So this equation is applicable only from 0 to 3 meters. Then for the case where the unit load D is here, so that's 3 meters, and we have FDC, and the shear theta D considering A and D. So we have FDC plus 1/2 of 3 times 3EI. The distance is x minus 1, because the location of the centroid of this triangle is 1 meter from this leg, and because that is x, so the distance of the centroid to this point D here is x minus 1. So FDC is 1/2 of 3 meters times 3 over EI times x minus 1 equals 0. So that would be FDC is negative 9 over 2EI times x minus 1, and we can make this positive 9 over 2EI and make this 1 minus x. So FDC equals FCD equals 9 over 2EI 1 minus x for 3 meters less than equal to x less than equal to 8 meters. So this is applicable from 3 to 8 meters. So this is now the influence line for vertical deflection at C. So this is FDC, which is equal to FCD 1 over 6EI quantity x cubed minus 9x squared. So this portion, the straight line, is 9 over 2EI times 1 minus x. And this value, substitute here, x is 3. 3 cubed minus 9 times 3 squared, negative 54 over 6, so negative 9 over EI. We can also substitute the deflection, value of deflection when x is 3, vertical deflection at C when x is 3. So 1 minus 3, negative 2 times 9/2, so negative 9 over EI. And here we only substitute it here because this is the equation when x is 8. So 1 minus 8, negative 7 times 9, negative 63 over 2. So negative 31.5 over EI. And this is the influence line for vertical deflection at sea by the conjugate beam method. And the unit is meter per kilonewtons.